Welcome back. This is the synthesis method number 3 of for an alcohol. And if you notice, the reactant, one of the reactant is essentially the same, and the second reactant is different. Now, as with the mercury acetate and with the BH3 and hydrogen peroxide, this is osmium tetroxide. This is, you may not remember it now, but we did do a reaction exactly the same in Chem 330. Okay, so this is osmium tetroxide. Okay. Now, the unique thing about osmium tetroxide is it produces cis products, and it does so by adding two OH groups to the carbon containing the double bond. All right, so you're going to be end up adding two OH groups, one here and one here where the double bond is, but the reaction goes through this intermediate, which I would recommend you remember it for time being. I may test or may not ask you what the intermediate looks like, but this is what the intermediate looks like. Now, don't confuse the O with the osmium. So this is what the intermediate looks like. And the product would be this. Now, I'm going to write two products. Both are possible because they're both cis. Now, as I said earlier in the introductory videos, you can have both as open, both as closed, or both as open. When that situation exists, then that's a cis product. So you can also have this okay. Something very unique, not in this particular case, but I'm going to show you another compound where you can expect this. This is a cis configuration, right? So basically, you've added two OH groups to where the double bond was, and we have cis, right? Typically, cis compounds exist in a state called meso. You know, what does meso means? It means a plane of symmetry exists. Now, this particular compound does not have, even though it's a cis, it does not have a plane of symmetry, because let's say I chop it right here, okay? Does the two parts of the molecule look the same? No. So no meso. It is cis, but no meso. How about we take this? Instead of that methyl group, what if we just started with the cyclohexene and added everything the same, the osmium tetroxide, pyridine, and H2O2? What would my products? Again, as I said, if you're adding the osmium tetroxide, you're going to have a cis product, means you can have both of them to be, you know, closed, or both of them to be open. I'm just going to keep it closed here. Not, I mean, not that this, whether it's open or closed doesn't matter, but make sure they're both closed in this case. And this is a cis. Now this is also a cis compound, but it also exists as a meso. Why? Because there is a plane of symmetry. This is the top part, this is the bottom part. One portion looks exactly like portion 2. So the one good thing about osmium tetroxide is it can produce, not always, it can produce meso compounds. Meso compounds have a plane of symmetry, okay, which makes the molecule appear identical at the top as it's at the bottom, right? So the top compound also, I mean, you would always generate a cis compound, but in some cases, a cis compound can turn out to be a meso compound as well. We saw that in the top case, because of that extra methyl group popping up, does not make the molecule equally the same on both sides when chopped up, whereas the bottom one, when you chop it up to two pieces, they look the same. So it's cis and meso. The top one is cis, but not a meso compound. So each ingredient bring with them that unique character or flavor that you may have to remember. So osmium tetroxide results in cis compounds, and occasionally the cis also turns out to be a meso compound. All right, so stay tuned for number 4.